Hello, welcome to another video on algebraic topology. In this video we are going to discuss two important results. First one is the Brouwer no retraction theorem. Using this theorem we can prove one more result that is called the Brouwer fixed point theorem. So first let us see the Brouwer no retraction theorem. The statement of the theorem is the unit circle S1 is not a retract of the closed unit ball B2. Again, I repeat, the unit circle S1 is not a retract. It is not a retract of the closed unit ball B2. Let's see the proof. Suppose on a contrary, we just suppose that this opposite is true. On a contrary, that S1 is a retract of the closed unit ball B2. So we suppose that S1 is a retract of the closed unit ball B2. Then there must be a retraction. If it is a retract, then there must exist a retraction. So that retraction can be chosen. So let f be that function, continuous function f from which exists from B2 to S1 be the retraction. And we define a homotopy, and now we are now moving to define a homotopy from S1 across I2, from S1 from the cross product of S1 and I to S1. We can define using this function f, continuous function f, we can define a homotopy H from S1 cross I to S1 by h of xt is equal to f of t plus 1 minus t into x1, f of t plus 1 minus t into x1 comma then 1 minus t into x1 minus t x2. See, these are the two coordinates. First coordinate is t plus 1 minus t, t plus 1 minus t into x1, and the second coordinate is 1 minus t into x2. And these two coordinates are applied in the function f. See here x, this is now defined. This is defined corresponding to the point x equal to x1, x2 belonging to s1, and t belongs to I. Since f is continuous, so h must also be continuous. Also h, see hx0. Let's think about the specific values of t and some x's. So hx0 equal to by substituting t equal to 0. When we put t equal to 0 in this expression, we get that here it reduces to x1, and this one reduces to x2. So x1 x2, we get f of x1 x2. When x equal to 0, when t equal to 0 is substituted, then we get f of x1 x2, but f of x1 x2 equal to fx equal to f of x equal to x, and h of x1 equal to f of f of 10. See, f of 10 that equal to 10. F of 10 equal to 10. Okay, and then we have h of 10s. See, the point at the point 10s, h of 10s is equal to f of t plus 1 minus t 0 that equal to f of 10. F of t plus 1 minus t, that is 1, f of 10 equal to 10, and this shows that h is a contraction. This shows that thus h is a contraction, but s1 is since s1 is contractible to 1, but since s1 is contractible to 10, it's a contradiction to the theorem 5.7. See, and therefore thus we get that h is a contraction, and this means that s1 is now contractible to the point 10. So it contradicts the theorem 5.7. Okay, and that is s1 is not contractible to s1 is not contractible. That theorem says that s1 is not contractible to a point. And therefore S1 is not a contract of the closed unit ball. See, and therefore S1 is not a contract of the closed unit ball B2. So our assumption or loose assumption must be corrected here. You have just assumed the contrary part, that is S1 is a contract of the closed unit ball, and this must be corrected. It is corrected as S1 is not a S1 is thus it is not a retract of the closed unit ball B2. Okay. Next, we can using this theorem we can prove the Brouwer fixed point theorem. It states that every continuous function f which exists from B2 to B2, a continuous function f is different from B2 to B2. That here B2 is the two-dimensional ball. From the two-dimensional ball to the same space has at least one fixed point. So there must be at least one fixed point for every continuous function which is defined from B2 to B2. Here also we will prove it by contradiction. Proof it will be by contradiction, and for that we suppose the contrary is true. That is, there exists a function f from B2 to B2 which fixes at least some points. See, then suppose this function f is continuous. If f is continuous and having so here we assume that f is defined from B2 to B2, which is actually it must fix some point, but since we assume the contrary, we have to think that the function it's continuous and it does not fix any point. So if it does not fix any point, then there must exist some point such that x and fx are different. See, we take such a point. Let's take for all points. Since it does not fix any of the point, then for all point, we have to say that x and fx are different. So here for any point taken from B2, the value x and the function value fx are different. So based on this assumption, what is the assumption? We have assumed that it does not fix any point in B2. The function does not fix any point in B2. Okay, and we have the figure. In this figure we have taken the points x, so the point x is taken, and also fx. Both points are marked, x and fx, and since they are different, we can draw a line. Joining a line segment can be drawn joining the points x and fx. It's only because these points are different. We have two different points, so we can draw a line, and that can be extended from fx to x. It is drawn, and it can further be extended so as to meet with the circle, the boundary of the circle, and it goes outside. So we consider a half line which starts at fx and passes through the point x, and it cuts the circle at the point hx. We take the meeting point of the half line with the circle as hx. And since the point x, we can also see that as the point x continuously varies in B2, the function, since f is continuous, the function, the movement of fx, the point fx also on the fx is also in since the function f is different from B2 to B2, the point fx is also present in B2. So as x moves continuously in B2, you can see that fx also, its image fx also continuously moves. As a result, what happens here, this line segment joining these 2 points, line segment joining the points also continuously moves. As a result, that movement of hx, then you can see a movement of hx corresponding to this changes in x, in the position of x and fx. We can see, we can experience a change in the position of hx also. That also moves along the circumference of that circle, and that movement is also continuous. So in other words, hx changes its position continuously along the circumference of the circle. That means the function h, if you define a function based on this image, or based on the point, based on the intersecting point, that function will also be a continuous function. And we are going to define a function that way. So for x in B2, consider the half line from fx to fx through x, and that means hx meets the circle at the point hx. Denote the hx denote where the hx denote the intersection of the line with the circle. Now we define the function h from B2 to S1. We define the function h from B2 to S1. It's also this function is clearly onto. This function is clearly onto, and also ha equal to, see, suppose h of a equal to a for all a belonging to and we can see that, I can also see that ha equal to, this function have the property that h of a equal to a, whenever the point a belongs to S1. If a is a point of S1, then ha equal to a, or the point is mapped to the same point. Yeah. And since f is continuous, h is also continuous. Therefore, see, therefore h is a h is a retraction from B2 to S1. Thus we get that we can say that h is now a retraction from B2 to S1. But this contradicts the the previous theorem. This contradicts the fact expressed in the established in the previous theorem, that is the Brouwer no retraction theorem. Brouwer no retraction theorem says that there is no retraction from B2 to S1. So since that is proved, you cannot accept, you cannot now proceed with this contradiction. Okay, so you have to correct it. How can we correct that contradiction? Just by changing that assumption that we have made in the beginning. In the beginning we have assumed that the function there exists a function, continuous function f from B2 to B2, which does not fix any point on B2. Okay, and that was the loose assumption that we have taken. So this contradiction finally that we have obtained here might be due to that assumption. So we have to correct it. So it can be corrected like every continuous function which is defined from B2 to B2 fixes at least one point. Okay, that's the end of by this we come to the end of that the result, the fixed point theorem, Brouwer fixed point theorem. Okay, thank you.